Okay, welcome to our class. We want to look at a concept we are familiar with in Noir, a concept of zero knowledge proofs. So this is where I begin from. So of course, we know what zero knowledge proofs are. We want to write a circuit, for instance, so that the verifier does not know our secret, but we can convince the verifier we know what it is. We know X, and at the same time, we do not want the verifier to know what that X is, but the prover must know. The prover must know what X is. Now, so the first example we look at is how to write a circuit that shows that you know two numbers make whose product is known. For instance, a composite, you have a composite number. So the verifier knows the composite number, but does not know the product that brings up that composite. So it cannot factorize. But you know the two numbers. For instance, you know A and B, such that the product of A and B is C. So the verifier knows what C is, but it does not know A and B. So that's what an example we want to write. So that is what I say, zero knowledge proof of compositeness with the Noir. So this kind of circuit has various applications, and we'll be seeing the applications, and of course, as we go through the steps. Now, this is just what we know, what zero knowledge proof is. And zero knowledge proof is a protocol where a prover convinces a verifier that a statement is true, but the verifier is not supposed to know what the statement is. So it's zero knowledge because no information about the secret is revealed to the verifier. So the verifier will just know that that statement is correct. Example where you can apply this in password proofs, privacy blockchain, and so on. So the circuit we will write today, you can generalize it later. You can use it to write several other circuits out of it by just following the same trace tactic. Now, so the motivation is to prove a number is composite and prove that a number is composite without revealing its factors. And as I've already said, this can be used in privacy-preserving math, cryptography, and education. So the same simple circuit can be applied in so many other areas. So you can just take that, after you've taken that circuit, you can now rewrite it to do something else. Just the same circuit can be rewritten to do something else, some other work, and so on, but the same circuit. So usually the circuits that are used in zero knowledge proof are not very complicated circuits. They're just circuits we know, very simple, but now they can be applied in very many scenarios to perform different duties in privacy preserving. Now, so the goal of our circuit is given a public number M, we want to prove in zero knowledge that we know two non-trivial factors A and B such that their product gives us N. So the verifier will know what N is, but so N is a public value, but A and B remains private. So non-trivial, we don't want to pick values where A and B are ones. We want them to be bigger values. So we don't want N to be one, so that B and A are also one. No, we want a composite number where A and B are bigger than one. So that means, therefore, the circuit will write, if anybody was to input A to be 1, that circuit is supposed to reject. That would be a wrong entry. If you input B to be 1, again, it's supposed to reject. That would be a wrong entry. If you input A to be N and also B to be N, it is supposed to reject. So that is how we're going to write it. So that you don't tell us that N is A, that N equals to A, so that B becomes 1. The circuit is supposed to reject that. Now, we've already said why we do not want to reveal the factors. In zero knowledge, we want them to be secret. We want the factors to be private. Some of them, because they are sensitive. For instance, cryptographic keys. These are factors. So you don't want them to be revealed. When you are looking at something like the RSA, you're looking at the RSA, you don't want to reveal some information about this. Let the product maybe be known, but not the factors. So you can see this can be applied in RSA, can be applied in so many other areas. You just need to apply it. But once you know how to run the circuit, in zero knowledge, you can now try to see how to bring in various ideas, RSA and so on, and use it. So the verifier is supposed to know only the composite number, but not what makes it composite, what the numbers that multiply to get it. Now, so we'll be doing this in Noir, and I know that you had earlier on installed Noir and Nago, so it would be easy for us just be going straight to what it is and doing it. It's a very simple circuit, just this. This is the circuit I'm talking about. But then we shall now go and I show you how to write it until we generate a proof and verify that proof. Now, from the main function, you can see that A is private, B is private, N is private, but the result is public. So we note if it's public, you use the word pub. So you can see the result. This means what comes out of A times B is supposed to be public. It's a field. If it would be public, we would have put the word pub here. Would have put the word pub, but the word pub is not here. So it means this is private. Even this B, if it were public, you would have put the word pub here. But since the word pub is not there, it means this is private. If you want them public, you can put the word, but then it ceases being zero knowledge. By being zero knowledge, it means something has to be private. You don't want something to be revealed. And there has to be another one which is public. So that is what we mean by zero knowledge. Now, so we assert, and I had already said, I'd already said that A is not supposed to be equal to 1. So this is what it is. Assert A is not equal to 1. Assert B is not equal to 1. Assert A is not equal to N. B is not equal to N. Then assert that their product is N. So then this is the outcome. This is the outcome which is public. So this is what we will be doing. But I'll want you just to Are you on my? Can you access my GitHub?
Yes.
Okay, so I wanted you to clone an example in Composite. That is the one we'll try to work with. I can even give you the link. You are on. You're using WSL. Are you using a WSL or what? Do you have it?
No, I'm using Mac. No, I'm using Mac.
Or it
Mac.
can it clone?
Yes, it can.
Okay, so the link of what I want to clone is this. I've shared the link. How do you clone? It's supposed to be git clone. It's supposed to be git clone, then the link dot git. So now you can use this. I think it's git clone, then the link dot git. That gives you everything that is in that repo. And then after you've cloned, I want you to share so that I take you through a few things here and there. Once you have cloned, you just let me know so that I can share and then you share.
Okay. Okay, I've cloned.
Oh, okay. So, are you able to open it?
Yes.
Just open it and share.
Okay.
Yes, Nelly, how are you?
I'm good. I was late for some minutes, but I'm here.
Okay, welcome.
Thank you.
Now, so Lynette, where's your terminal?
There it is.
Okay, now, that is our main. What I'm seeing is our main. And this is the one above is our main function that is proving that you know of two values A and B that are not equal to 1 and n, but their product is n. And then we have tests. Now, so just CD circuits. Okay, now you can do Nago compile. We see whether it's okay. Compile, is that okay? Compile successfully. And that process has given us a target. You can again delete target, just delete target again, we do it. Okay, again, do Nago compile. Target has come and it has our witness. It has our witness called ZK composite proof Noir.json. Now, normally this name comes from the Nago toml. When you check Nago toml, you find that name there. Just click Nago toml, and that is the name ZK composite. So if you change that, the name again will change there. That is where it comes from. Now, so you can delete the prover.toml, prover.toml. Okay, that is okay. And now do Nago check. Do Nago check. Just given us our prover.toml. And now click on it. Let us fill those values. A, we can give A any value. Which value is that? 7, huh?
Yeah.
We can give B another value. That's 119 or 19.
Okay. Yeah, 19.
Okay, what about their product? 7 times 19 will be, their product is N. That will be 133. Now, if it's correct, when you do Nago execute, it will run. Okay, so it's correct. Is that okay? It has said, it says circuit witness successfully solved. Witness served to target that circuit output is 133 and is okay, that is correct. Now we have, you can see something there called build.sh. Now that one is meant to run Nago compile, is meant to do proof key verification key generation. So that is why you can see part 1 is compiling circuits. So without doing Nago compile, when you do this, it will do Nago compile. Then after doing Nago compile, because it requires that witness, it will use it to generate a verification key. Then after generation verification key, it will also proceed and generate verifier, solidity verifier, which we also call contract. Now, the solidity verifier would then be served inside contract as verifier.sol, to be served as verifier.sol. But then the verification key will be served inside target. So I'm just reading that line 11. Line 11 says, write verification key oracle hash, kekak, and so on, then store it inside the target. That's what it's, the last line, that same line, that's what it's saying, the target. So it will be stored inside target as ZK composite proof Noir.json. Now that, okay, it will use that to generate the verification key. So what it will write the verification key, but it's going to use the witness, which is called ZK composite proof Noir.json, which is inside the target. We already have that.
Yeah.
We already have that. So that is the witness. And that is what it will be using now to generate verification key. Now, so to run that build, you do dot. It's dot. Yes. Build.sh. It has run successfully. And now when you check, you can see VK inside the target. Inside target, you can see VK. So that is a verification key. Now, so we are done with that part of the circuit. We can now get in outside circuit. The verification key, you cannot see it. That one, you can even delete it. That verify.sol, delete it, and we can again generate it. Just delete it. After deleting, you have again to run build.sh. It's the one that generates that.
Yeah.
Yes, the one that generates, because we said it should generate and then store it inside circuit, inside contract. So that one, you're not writing it your own. It comes naturally. Once you run, that is the contract. When you scroll it down, you'll see there is contract. Just scroll it down to the very end. Yes, that last line, line 1879, says this contract is called pass honk verifier, and so on. So this is a contract. If you are to deploy it, then this is the contract you're supposed to be deploying. Now, so we are done with that bit. So the only thing we are writing here is the main.nr. After you've written main.nr, you may want to write build.sh. Although the steps that build.sh has done, you can even do them manually. We are just writing build.sh to ensure that we are not doing things manually, but you can still do it manually. But if you don't want to do it manually, then you require just the main.nr, the build.sh, the nago.toml, the prover.toml. And then these other things, I'll show you how they come. We've already seen how the verify.sol comes in. Now, so we have JS. Now get out of the circuit, cd ... We get inside, let's get inside the JS.
Inside. Oh.
Okay. Now, so we want to generate a proof. And just before we generate that proof, let's do some changes on generate proof.ts. Generate proof.ts. Okay. You can see it's red.
Yeah.
It's red. It means there is an error. So the error is on the value A on number 13. Line 13, your A is 7. So make it 7. Your B was 19. and your n was 133. So the error is supposed to now disappear.
I think we're supposed
Oh,
to
the others are just warnings, which have no, they will not affect anything. Like that one is just a warning. The ones in red, those ones will not affect anything. Let's go to our test. Let's go to our test. The one in contract. There's contract there, just to be above JS. There's contract. Down below contract is test. Down below contract. Yes.
in this file.
No. Inside contract, can you see something called test down there? Yes, that one. Yes. Now what I want there is starter.t.sol. Now under that, we want to make a few changes. Are you seeing line 17?
Yes.
Yes. Your public input is 133. Yes, that is our public input N. The rest remain the same thing. So just change that and everything will be okay. Now, so there's no error here. It will just compile. There's no problem. We are inside JS. Now let's go to our readme. Just click it. Now the commands that we'll be using are here. Just scroll down. We have yarn generate proof, proof generation. Just below this, there. Line 114. Line 114. Yeah. Yarn generate proof.
Let me start with the yarn install to add the dependencies.
Oh, you don't have it?
No.
Yes, that is okay.
Okay. So yarn generate proof.
Okay, try that. Let's see. The proof is okay?
Yeah.
Yes. Now that proof has been saved inside target. Let's go to target and see the proof. Good.
Okay.
Below that proof, we have public inputs that are written in hexadecimal. Just click on it. Hexadecimal. That value 85 is the equivalent of 135, 133 in hexadecimal. You remember when you're doing in hexadecimal, you will take 133 divide by 16, and then the remainder is supposed to be, I think, 8 or 5. One of that is supposed to be remainders. You normally write, let me just see, what's the remainder? 133 divided by 16. It goes there 8 times, but the remainder is 5. The remainder is 5. Then again, you ask yourself, 16 into, it had gone there 8 times. So 16 into 8, the remainder will be 8. So that is how we get that 85. This 85 is just 133. That 133 is a decimal form. But now, Noir does this in hexadecimal. So that is why you're saying 0.0000085. This is the hexadecimal equivalent of 133. Now, so we've generated the proof. The next step is to verify the proof that we've just generated. And we do verify inside contract. So you get out of JS, get inside a contract. Okay. And what we are using, just scroll our readmes down a little. Yes, that is the command, line 136. Has it run? Okay. It has now run without errors, I think.
Yeah.
Yes, without error. So the proof has been verified. We've now verified the proof. Now that is one way of generating a proof. We've done that using JS. The other way of generating a proof is we can use the CL. So we do it inside the contracts. No, inside the circuit. So let's get outside. Let's get outside and get inside the circuits. Okay, so we want a witness. First of all, we do now go execute. Good. Now, after Nago execute, okay, we've had something generated there. Now, after Nago execute, you can generate a proof. Just scroll them. There's a readme up a bit. Yes, there. Line 124 is the command we are going to use now to generate the proof. That is the other way of generating a proof. Okay, the proof has been generated, and again, you can see it in target. Of course, it just wrote itself where there was another one, but public inputs you can see twice, and one is not visible, but it's just the same thing. So the one that's not visible is the one that we've just generated now, but it's the same as the one that we already have. We can again verify this proof the same way we did by getting outside the circuits and getting inside the contracts, and then using the same command.
Yeah.
Okay, so this same circuit, you can just play with this and make as many circuits as you can by just, the only place you change will just be the main, change the proof, then the prover.toml, the nago.toml, and then you saw us changing what? Yes, starter.sol, and you also saw us changing generate proof.ds. Those are the only things we change. Now the starter.sol, the only place we changed was the value, the place of the public inputs. The public input, and again, when you check line 12, you are saying how many public inputs there are. You can see I've written there 1. So if there are 2, you just state 2 instead of that 1. And line 17, if you have more than 1 public inputs, you are listing all of them. For this case, we only have 1. So you have it there. But if there are several, you would list all of them as public inputs there. Now, if you just click on the line after starter.t.sol.
Which line?
The when you go to the right side, there's that CPN verifier.app, that one.
Yeah.
Now, I'm referring to line 27. Line 27, I've said the length is 1. That length refers to how many public inputs there are. So if it's 1 public input, you just say length equals to 1. And so the reasoning is that it expects 1 public input. So you can change that to 133. You can change that to 133. That is okay. Good, because that is our public input this time. Now the rest remain the same thing. You may just want to change maybe the naming and on, but the rest remain the same thing for this. You can even delete the other part from line 4 to line 7. You want to delete that because they have no work here. So what I mean is you can edit and make it look yours if you want, but it has no impact. There's no problem. The rest remain the same thing. And let's go to our README. Let's go to our README. Okay, just scroll up and we want to change the circuit. This time we've changed the circuit a bit. No, we didn't change our circuit. What we changed was the prover.toml. So the circuit, this one is the same way actually. We have not changed anything here. It's the same thing. Good.
Okay.
Now, so if you want to do what? Just a minute. Okay, here. If you wanted to, for instance, let me say you want to have pull requests. I'm assuming that your pull request, you want it at, I'm looking at where do we share? Where is this? The chat, I'm not seeing. Oh, I've seen it. If you wanted to do pull request to crypto, I've given you a link. You can try. Let's clone that. Just clone that. There's a link I've shared in. But before that, let's send it to your. Just send it to your GitHub.
Okay. I think I have to create a repository for this.
Yes, yes. So just go to GitHub and say new. Then give it a name. Give it a repo name. The repo name can just be the same name we have on in our Nago terminal, or you can change it a bit. There's no problem. You have created a repo.
Yes.
I'm not seeing your screen. Just show me so that we work with that. What you. just
Let me share
created.
my
And share
screen.
this and then share. Yes, yes.
This one.
Okay, so that's good. So this is the name is composite and so on. That is good. You said you're working on your Mac or what is it?
Yes.
Okay, so how do you normally proceed? You do git add, or what do you wanted to?
First of all, I'll initialize the new Git.
Just do that. Git init.
Wait, Git.
In the roots.
Yes.
Okay. Oh, that one. Oh, it was facing somewhere else, huh?
Yeah, I think
That is
it's
okay.
since I've cloned, it's still linked to your.
Yes. So removing it's okay. That is. And what did it say? There was an error.
I think I'm supposed to do git remote remove, and then the name. So it will be.
Are you still getting the error?
Wait.
What?
The link to your GitHub.
It's still pointing there. Right.
Yeah.
You can do this. Say git remote remove origin.
Okay.
Git remote remove origin. That should now should change it. Git.
Yes.
Have you done that?
Yeah, it has worked.
Yes. Now go to your GitHub and copy your link. The link, where was that? Yes, that git remote add origin. Copy that and paste.
Okay.
What does it say?
I
What does
think
it
it has worked.
It has worked, huh? Now, for you to know that it has worked, say git remote -v. Git remote, then space -v, for you to know that it has worked. It should be reading yours now. Yes, so
Yes.
it means it has now worked. So at that point, you can now say git status. Let's just see what is there. Okay, that's okay. Git add, then space and dot. What is that? Oh,
This
okay.
is
You're committing now, yes.
and
Okay.
then git push origin me.
Okay. Give it some time. Has it gone? Still going, yeah?
Yeah.
Okay. Just in 1 minute time, I think it will be done, 1 or 2. Now, so as it goes, you can see our GTEM ignore is ignoring target and so many other things. So our target will not go to GitHub, I think.
Yeah.
Circuit target, yes. It's ignored, and all those are ignored. Even yarn and so on. I did not ignore the rest. There are some pretty and so on. Those ones you can always let them be there. It's not of ignoring all of them. So I think it has gone or still going.
No, it's yeah.
Or it could just be maybe an issue of internet. So just give it
Yeah.
some time. I think we would even have ignored this thing called contributing, this thing called license, all these things here. I think we would have ignored them before committing, but there's no problem. But are they really heavy? What do they have? This one comes as a result of installing Forge. So we didn't even require it, we will have deleted it. When we install Forge and Foundry, so this is what comes with it. So that is why it's here. So it's not even relevant to our work. What is this license Apache? I think it's also as a result of that installation. They are not very relevant to us. We would have deleted them. When we delete them, it means again we have to commit because they're already committed. But just delete, they have no work. What else are you deleting? Contributing, yeah? Okay. These others, leave them. How many foundries do you have here? Am I seeing two?
Yeah, these two. There's this one for the forge STD.
Okay. There's no problem. Just minimize that forge. Just click it. We see where on forge. But it has already gone. Eh?
Yeah.
It has already gone. Just let's see.
Mm. Yeah.
Okay. Yeah, that is okay. Now, so you have the link. There's some link there. I've shared some link. You have seen it, eh?
Yes.
Okay, so you can clone. What are you looking for?
The terminal.
Okay. That one is heavy. It will take a bit some time, maybe 5 minutes. It's a bit heavy because you are cloning the entire repo, and it's has a lot of things. Is it the same terminal we're using? Or the other one was a VS Code?
Yeah, this was the usual terminal, and then this other one was for VS Code.
So this for VS Code, you can also commit what you've just deleted. There's something you've deleted there. I can say again, you can say git inish. Inish. Initiate, yes, that one. Initialize. Okay, so maybe look at the status again. Git status. Yes, we have deleted something. Is that okay? Or does it say deleted? What is
No,
it
it
on
just
the left?
says modified. Where?
On the left, that in red. You see something in red?
Yeah, modified in this
Oh,
in that folder for JSTD.
okay. Okay, proceed and git add.
So
What does it say?
it's saying I've not staged those
Oh, the
changes for
changes.
commit. Let me try again.
Mm-hmm.
Let me try with the name of the.
Try with the name of what you've changed.
It's in contract.
Can even just say contract. Or you,
Okay.
I think contract, okay. That's accepted, eh?
No, it's still saying changes not staged.
Okay. Yes, I think it's just, it's not being sincere. Okay, but there's no problem. Let's see what is online, what we put online. Whether it has what we want, everything that. Okay, click on circuits. Is it clickable?
Yeah.
It opens. Okay. What about JS? Because sometimes they can come as a link. So you need to know that they're all working. JS is okay. What about contract? So they're all okay. Okay, what about our cloning? Is it almost done?
Yeah, it's done.
Oh, it's done.
Yes.
Okay. Now, if that is done, then that is okay. So CD, crypto systems.
And then I open it in.
No, you don't open it. There's no problem. Just CD it. I'm not seeing where you're sharing. Oh, okay. You've already done that.
Yes.
Yeah, we don't need to open it. Now I'm sending you this some what you will now just paste so that begin from there. Just sending you this. So you can now paste this.
I ran that one.
Oh, we've already cloned. Huh?
Yes.
Now run that. Have they all run?
Yes. Yeah.
Press enter. Press enter for the last one to run. Has it run, the last one?
Yeah, they've all run.
Or they all run is okay.
Yeah.
Now, so we just want to be sure that we are working on we want to work on the right repo. So you'll just change from Noir, the link that I've given you, this command change from Noir, replaced by your repo name. So it should read git checkout -b add dash, then your repo name.
It was like that.
What is your repo name? Your
ZK
repo name is ZK.
composite proof now.
That's okay. That's okay. What
Okay.
does it say?
Switch to a new branch, add ZK composite proof noir.
So we are on a new branch now. That means we are proceeding well. So we now make directory, and again, I'm sending you the link. Just want to make a directory migrations. First of all, press the first one, make directory migrations. That one alone, first of all. Good. Now this other one, we will edit. We'll edit. The year is 2025. That's okay, but the month is 08. The time, the day is 21. Today is 21st. So you just edit it here, and then so I've said you are editing. The year remains. The months. This is 08. You're getting it. Is that okay?
Yes.
And then the date today is 21st instead of 04, 21st. Then a time, T means time. You're putting the exact time, 21, from my side is 21:24:00. 21:24:00 from my side. I don't know your side, 00. Then there is that underscore, add, dash. After dash, you write your repo name.
Okay, will the name have dashes or underscores?
No, the name just the way it is from your repo.
Okay.
Yes, that is just your repo name the way it is. See your repo name, you can have it underscore or dashes. So, but it has to be your name.
Okay, yeah, like that.
It's okay. What does it say?
It has opened.
It has opened Nano.
Yes.
So now we want to, are you still able to see what I'm sharing? So that we edit it again together and then you paste inside Nano.
No, I can't see.
You can't see?
No.
You can see it?
No, I can't see your screen.
No, I've pasted on
Oh, okay.
the chat.
Oh, yeah, I've seen it.
You have seen it, huh?
Yeah.
Now, repad remains, Noir lang remains with those quotation marks. Now, the name of your GitHub changes. So what we change is the username. Instead of Cyprian Sako, you put your username. No, you can't change from there.
Where?
Is it possible to change from here? From Nano, it will be deleting.
Yeah, I think we can change.
You can change, eh? Okay. Now, so there's no problem where you're going. You're just changing the name Cyprian Sako to your name.
Okay.
Okay. Edit and can it edit? Can it write? Okay,
Yes,
good.
it can.
Good. Just continue, write your repo name. And then again, remember to change what we just did today. It is ZK.
Composite proof noir.
Okay. Now you can even delete the example or leave it. So what we have there is example, ZK, circuit, Noir, Aztec. You can delete the last one, the PSI. That one you don't require it. Now you press Control O. Control O. Have you pressed Control O?
Yes.
Okay, now just press Enter. Have you pressed Enter?
Yeah.
Now
It
press
says
Control X.
okay.
Now press Control X. It takes you back to, for us to continue doing a few things. Now, so we can do git add. Let me just again send you so that we edit a few things. These are just the steps. The first one has no problem. The second one has no problem. It's the third that we're going to edit so that it agrees with yours. So the first one is git add with a dot after add some space. That has no problem. And then git commit. Again, that one has no problem. Okay, add. Then this time you're writing the name of your repo. Is it that?
Yeah, ZK composite proof Noir.
What did you write at the end? To there?
Yeah, it's up to there.
Okay, there's no problem because that have you already pressed enter?
Yes.
Okay, so you can do. We shall edit it when we go to the new. We needed to add to the Noir ecosystem, but we shall edit it when we go there. Now, so git push origin, add again, then the name of your repo. Okay. Is it successful?
Okay. Enable. Oh, it's pushing to your fork of the crypto ecosystems. Should it be pushing there?
No. Is there something we pasted about my?
Oh, the repo that I cloned. This one.
Oh, you cloned mine?
Yeah.
No, I had given you some link to clone.
Yeah, it was this one.
No. Has it done that? Has it already?
No, it's not pushed.
It's not pushed.
Yeah.
You don't have this crypto something cloned in your repo?
No.
Yeah, there's a link. Let's go to that. Let's go first of all to just click that link that Nell has shared. We go there and is it that?
Yes.
Fork it. Is it? Yes. Good. That way is okay. It's okay. Now let's delete the one we cloned that is mine. Have you forked it in your? Is it in your repo now? Is it on your GitHub?
Yes.
Can you see it in your GitHub?
Yeah.
Can you see it in your GitHub?
Yes, it's this one here.
Okay, copy that link. That is the one we shall use to clone.
Okay.
That's the one we shall use to clone. Have you removed that? It's remove, and then space dash RF. RF. Yes, yeah. Has been removed. Huh? Yes, that has been removed. Now clone that. And let's give it some time again.
Okay.
Now, so that one, once you've cloned it, you can always be using it. You can always be using it. You only need to fetch the upstream so that it's in line with what is on your local machine. Or if you want, you can delete the one on the local machine later, but every time you'll be cloning it the way we are doing.
Okay, so it's done.
Has it completed?
Yeah, it has.
Okay. So you've done CD.
Yeah. CD
Oh, yeah, okay. You're just following those commands, huh?
Okay.
The same commands from the top.
Okay. Yeah.
So maybe when you reach to where we had the timing, that is the only place you'll change the time.
Okay.
Oh, it's already there. Make sure it's only one line. If there are two lines, you delete one.
Yeah.
I can see two lines. Are they? What I must?
No, it's one line. This one.
Okay. Are there something I'm seeing like modified above? Okay, or that one is something different.
This one here.
Yes.
Oh, that's the file migration, like the name of the file.
Okay, okay, okay. Okay, so where have you reached?
Now git add.
Okay, okay.
Like this is good. I've written.
Yeah, that's okay.
Yeah.
That's okay. Has it gone?
Yeah. Yes.
Okay, now let's go to the ecosystem. That is crypto ecosystem.
The GitHub.
Yes.
Okay. I'm here.
You're there? Can you see compare? Yeah, that's okay.
Yes.
It's there. Now let's edit this first of all, what I'm just pasting.
Okay.
Can edit a bit just to suit you. Now the first one, we add a new example project. We just change the name there. There's no problem. Then your GitHub. Then again, the hashtags. We maintain the ones we had. We can remove the PS something. Then the rest remain. Just change the name of your repo in the first sentence and in the second repository. Just click on compare and paste them there, and then you can even edit from there. That one is okay. Just paste in the description.
What am I pasting?
I've shared something on our chat.
Oh, okay.
Okay, just move it to the left. Whatever is at beginning at the center, move them to the left. They'll be like links. Yes, that way. That one is okay. Now change the name weighted voting, replace with yours. Yes, voting circuit, replace with the
ZK composites. Okay. Yeah, that's good, right?
It's okay. You can always edit it if you want to change it. You can come later and edit, but for now it's okay.
Okay, so create.
Yes. Give it some time just to run. It tells you whether there are errors or not, but I know there are no errors. Okay, you can even refresh. You can even refresh up there. Okay, it's now okay. So the files changed a one, just click on that. Sometimes there are errors, you come and click on that and rectify there, but I can see it's okay, no long. Then the name of your GitHub, just copy that name of your GitHub, click it on the browser and see whether it directs somebody there. Check if it directs somebody at the right place.
Yeah.
Has it gone to the right place?
Yeah, this one.
Okay, so I just want I want us to make just some things light on that README.
Okay.
I just want to paste something there, something so that you can paste in your README, just something small. Can you see what I've shared on the chat?
Yes.
Now you can paste that in the README. Where's your README? Yes, click right, that pen, then go at the bottom and paste what I've just shared. Okay, let me see it. Okay, there's no problem. Now just commit. Okay, that is it. Now, so I think we are done. So those are the steps if you wanted at any given time to let me say submit on crypto. It's not the only place you can submit. A crypto, they just store they don't store your content, but they store your link. They store your link. So what they do is this link, there's a way they make it known. There's a way people visit their repo and they're able to see your link and then able to see what you have created. That is the only thing they do. So if you wanted, again, you can submit it in other journals, in other repos, GitHub, so that they can accept again. But this one is just for store. They don't store the repos as such, but they just store the link. The one where I was telling you must check and see whether it's pointing to a repo.
Yeah.
So they make it accessible to people, to various people. So people who are interested in that kind of circuit, they can always follow that link and come to a GitHub and see what is there. Yes,
Okay.
I think that is it for today, unless there's a question.
I have a question. You said we
Yes.
can submit to other repos. Could you give
Yes.
me an example?
Yes. So now you may want, you see, once you've created something like this, you want it to, you may want to do pull requests, just as we've done to this research. It's called what? Crypto ecosystems. You've done a pull request to crypto ecosystem. So you can also do some pull request to, let me say, Noir. You may want to do some pull request, let me say, to Noir examples. Just do the same thing. And elsewhere.
Okay.
So you just go to you go to the GitHub and see they are contributing idea, how they allow contribution. So you read on contributing, then understand how do they want you to contribute. How do you send? How do you submit your circuit to them? So that's what I mean.
So.
Yes, you can submit Nolang, you can submit it to no examples, and so on. And you create others and submit. But now, if you have any that you've submitted elsewhere and has been merged, you can also, again, just submit it here to the Capital Crypto ecosystem.
Yeah.
They store that link, the link for it to your repo, and then make it accessible to various people.
Okay.
Yes. Unless there's another question again.
No.
Okay. And Rita, Nelly?
No questions.
Mm-hmm. You're continuing with the is it called Fridays here or something? I saw some.
Yeah. Proof
It's
of
called
Friday.
It's called what?
Proof of Friday.
Oh yeah. But there was also proof of Wednesday.
So we switched it to Friday because most people say that they are more available and Friday is way better for them.
Oh, okay.
Yeah.
It's okay. Okay, thank you.
Okay.
Okay.
Good night.
Good night.
Night.